Hey, good morning. Let's solve the Leetcode 205 isomorphic strings. So the problem read, given two string S and T, determine if they are isomorphic. Two string S and T are isomorphic if the character in S can be replaced to get T. All occurrences of a character must be replaced with another character while preserving the order of characters. No two characters may map to the same character, but a character may map to itself. So when we read the problem, we can notice that isomorphic string should have the same size. So the first thing that we need to check is to make sure that the two strings have the same size. That's the first notice. And then we can also notice that the problem is mentioning some mapping. So we will definitely need to map character by character while traversing the two string. So we have a map that is mentioned somewhere here, and also same character. So we said no two character may map to the same character. So one character in the string S may map to one character in the string T, and that will not change. So that same mapping should happen while we are traversing the string. And a character can map to itself. So that means if in S there is one character, let's say A, and that map at the same order with another character A in the string T, that can happen. Okay, so let's explore some example in order to understand the problem clearly. Okay, so EG1 S is equal to 4 and T is equal to bar. So we have two string and two S equal to FOO and T equal to BAR. So if we start traversing our string, we can notice that S of 0 is equal to F and T of 0 is equal to B. So this is the first time, so we can have our map that have F that map to B. Okay, now we take the second character, S of 1 is equal to O and T of 1 is equal to A. It is the first time that is appearing, so we have O that can map to A. Now we have S of 2 that is equal to O and T of 2 is equal to R. So because O already appear in the map and O maps to the character A, O cannot map to another character. So this breaks the condition, and because we already processed the whole string, so the answer is false. Answer is false. So we traverse the string, and when we find a new character, we map that character with the character in the string T. We continue the traversing. If we found a new character, we just map that character to the character in T if they are different, or if they are the same, and if they don't appear in the map. And if we find a character that is already appearing in the map and that is not mapping to the character in T, then we just return false, we just break the condition. Let's explore another example of the problem to more understand. So EG2 S is equal to egg, and T is equal to add. S is equal to egg, GG, and T is equal to add. We can have our map here, and we see that E is mapping to A, G is mapping to D, and when we process S of 2, which is equal to G, and T of 2, that is equal to D, then we can see that G is already mapping to D in the map. So this is okay, and we are finishing processing the tree. So the answer is true. Let's take a third example. EG3, S is equal to paper, and T is equal to title. PAPER, TITLE. So at the index I equal to 0, P map to T, I equal to 1. It is the first time, so A map to I equal to 2. We see P again, and we notice that P is already present here, so this is good. P maps to T, that is already here. I equal to 3. E. It is the first time that E comes into consideration, so E map to L, and E maps to L. Yes, so we go to E equal 4. See that paper R map to E, which is different because R was not there yet. So this is, so because we finished processing, so the answer is, we finished processing and we haven't seen any mismatch, so answer is true. So in order to solve this problem, we need to maintain two two maps. Maybe one maps can do the work, but let's do two maps. Let's do two maps. Okay, so we have map 1, we have map 2. So let's have these two strings. Okay, so at I equal 0, C1 is equal to P, and C2 is equal to T. what do we do? So map1 does not contain C2, C1, and map2 does not contain C2. So what we do is we just add map1, we just add C1, so P map to T, and T map to P. So we take the second thing, I equal to 1. C1 is A, and C2 is I. So map what doesn't contain A, map 2 does not contain I, so we add A map to I and I map to A. We go to the next one. C1 is equal to P, C2 is equal to T. You notice that map 1 contains C1. In that case, we check if C2 is different to whatever map1 C1 is mapping to. So P is mapping to T, and T is equal to C2. So we just keep going, because if it was different, if C2 was different to what P is mapping to, then you will stop the algorithm and return false, because we just found a mismatch. We do the same for 2. So if C2 map 2 contains C2, which is T, and T is mapping to P, and P is equal to C1. If it was different, we just stop because we found a mismatch. Because it is equal, so we just continue. Okay. So now we go to the next one. I equal to 3, C1 is equal to E, and C2 is equal to L. So these two characters are not present, so what we do is we do E, we map to L, and L we map to E. Okay, so once we do that, we check. Now we go to the next character. I is equal to 4. C1 is equal to R, and C2 is equal to E. So R does map 1 contain C1? No, it doesn't contain C1. Does map 2 contains C2? No, it doesn't contain C2. So we can do R map to E, and E map to R. And because we have finished processing and we didn't find any mismatch, then the answer is equal to true. So we can now write the algorithm for this problem. Okay, so it's a Boolean function that we want to write, public Boolean. Isomorphic string S and string T. So as I said at the beginning, the first thing we need to check is if the string are equal. S dot length is different to T dot length. We just stop. because this will not work. Okay, so now we want to create a map character, and you call this map one is equal to hash map. Do the same here, map character, map 2 is equal to new hash map. So now we traverse the two strings for int I from 0 to I less than s dot length. You have char c1 is equal to